Hi, so today we're just talking about probabilities, and this video is just going to cover the basic concept of probabilities, just the foundation for what you need to know about probabilities before we move on into formulas or some of the more complex equations that go into probabilities. This is just going to be the simple basic concept of probabilities. You need to understand this concept before you move on into calculating different kinds of probabilities and all that. You need to understand this basic concept. So as you can see, we have a pair of dice here and some cards here. When you think about probabilities in terms of dice or cards, it usually helps. So if that works for you, then go ahead, be my guest, think of it in terms of dice or cards, and we'll give some examples here so to show you. So what you want to do in the steps is, the first thing you want to do when it comes to any kind of probabilities is you want to count the total number of possibilities that is available. Not the ones that you want to select, like say you want to pick a king out of a deck of cards. Not the kings. You want to count the total number of possibilities. If you just close your eyes and pick a card out of the deck of cards, how many possibilities are there? How many total possibilities are there? Well, the total possibilities is going to be the number of cards that are in the deck. So you want to count the total number of possibilities if you were to just close your eyes and select something at random. Number two is you want to count the available number of the type of item that you want. So if you want to select a king out of a deck, there are 4 kings in a deck of cards. So the available number of what you want is 4. And then you want to draw a fraction. You want to place number 2, the available number of the type of item you want, that's the kings, over the total number of possibilities, and that's all the deck of cards, all the cards in the deck. So here's some examples. For number 1, you want to count the total number of items or possibilities. How many possibilities of picking a card from a full deck of cards? Picking any card. So there are 52 total cards in a deck of cards. That means there are 52 total possibilities. If you were to close your eyes and just select a card at random out of a deck of cards, you have a 1 in 52 chance of picking any of the cards in there. Now also another example is how many possibilities of picking a flower from a garden consisting of 4 daisies, 3 roses, and 5 sunflowers. Well, 4 daisies, 3 roses, and 5 sunflowers is a total of 12 flowers, just any kind of flower. So there are 12 possibilities. If you just close your eyes and pick a flower out of this garden, then you could get, there's 12 possibilities of flowers that you could get. And again, here's some examples. There's 52 cards in a deck. There's 6 sides to a die. That's one die out of a pair of dice. If you just roll one of them, there's 6 sides. So there's 6 possibilities. If you roll one die, there's 6 possibilities there. And there's 12 flowers in that garden that we mentioned. So that's the total number of possibilities that we have. Number 2 is you want to count the available number of what you actually want out of that deck of cards or out of that garden. If you want to pick a king out of a deck of cards, you count the number of kings in those cards, and there are 4 kings in a deck of cards, so there are 4 total available kings in the deck of cards. That's the available number of what you actually want. So if you want to pick a king out of a deck of cards, there are 4 kings in the deck of cards, there are 4 available kings, so that's what you want to count. You want to count those 4 kings because that you want to pick one of those kings. Also, another example is what is the probability of picking a rose from that garden? And there are 3 roses in that garden, so that's what you want to count. You want to count those 3 roses. Next, you want to draw a fraction. And you want to put the type of item that you want, the available number of the item that you want, so those 4 kings or those 3 roses, and you want to put that all over the total number of possibilities to choose from. So that would be a 52 cards in the deck or 12 flowers out of that garden. So let's look at this example. Here is what we were just talking about. What is the probability of picking a king from a deck of cards? Now here's an entire deck of cards laid out face up so you can see the suits. And there are 52 of these cards in a deck of cards. So let's put 52 on the bottom of the fraction. 52. And that's the bottom of the fraction. So we want to draw the fraction line over that 52. The 52 is the total number of possibilities you could get, not the ones that you want, the entire amount of what you could get. And let's see, now that we want to count, number 2 is we want to count how many kings. If we want to pick a king, we want to count how many kings are available in that deck. Out of that entire deck, how many kings are available if you want to pick a king. So here's the kings row. So you have 1, 2, 3, 4 kings. 4 kings in that row. In that entire deck of cards, you have 4 kings. So we're going to put that 4 on the top of the fraction. 4. So if you want to pick a king from a deck of cards, there's a 4 out of 52 chance that you are going to pick a king. If you just closed your eyes and randomly chose a card out of the deck, there's a 4 out of 52 chance that you will get a king. Here's another example. Here is this garden that we talked about. As you can see, there are 3 roses, there are 4 daisies, and those bright yellow ones are sunflowers. Those are 5 sunflowers. So that's a total of 12. 5 sunflowers plus 4 daisies is 9, plus 3 roses is 12. So there's a total of 12 flowers in this garden. So let's put the 12 on the bottom of what's going to be your fraction, 12, and draw the fraction bar over it. And then the question is, what is the probability of picking a rose out of all of these flowers in the garden? Well, there are 1, 2, 3 roses. See, here's a rose here, here's a rose here, and here's a rose here. So there are 3 roses, and you want to pick one of those roses. So if there are 3 roses available, we're going to put that 3 on the top of the fraction. And there are 12 flowers in total, and that 12 is on the bottom of the fraction. So we have 3 out of 12 chance that you're going to pick a rose out of the garden. Now, of course, we can simplify this. 3 out of 12, and that simplifies down to 1/4, because 3 goes into 12 4 times, and 3 goes into 3 1 time. So that simplifies down to 1/4. So you have a 1/4 of a chance of picking a rose out of the garden of 12. And here it is written real pretty if you can't understand my handwriting. There's 4 kings available in the deck of cards, and that's 4 on the top, out of the entire amount, 52 cards, possibilities in the deck. That goes in the bottom. Down here, there's 3 available roses in the garden, so you write the 3 on top, out of the total number of flowers in the garden, which is 12. Now, what is the probability of rolling a die? That's 1 dice out of a pair of dice is called a die. So rolling a die and getting a 3. And as you can see here in the picture, somebody rolled that die and they got a 3 landing face up. Well, there are a total 6 sides to the die. So let's write 6. 6 is the total number of possibilities. So let's write 6 on the bottom of the fraction. 6 sides. 6 sides. And then on the top, how many 3s are on those 6 sides of the die? There's only 1 3. because each side has a different number on it. So there's only 1 3 available or possible out of those 6 sides. So we're going to write 1 on the top of the fraction because there's only 1 3 available. So that's a 1 in 6 chance, a 1 in 6 chance that you're going to roll a 3. So the probability is 1/6. Now, what is the probability of rolling a pair of dice and getting a 3? Well, one die has 6 sides to it. A pair of dice has 12 sides, doesn't it? Of course. So you're going to put the 12 is the total that we're going to put on the bottom of the fraction because there's 12 sides possible. And how many 3s are possible in 2 dice? Well, there are 2 3s. There's 1 3 on each die. So there's 2 3s. So we're going to put the 2 on the top of the fraction. So there's a 2 out of 12 chance of rolling 2 die and getting one of them coming up as a 3. It doesn't matter what the other one comes up as. You just want one to come up as a 3. And as you can see, this guy is rolling dice and 1 3 came up. Looks like a 3 and a 4, but 1 3 came up. So that's 2 out of 12 chance. And of course we can reduce that down. 2 into 2 is 1 time, and 2 into 12 is 6. So again, that reduces down to 1/6 of a chance that you're going to roll 2 die and a 3 is going to pop up. And here it is again, one side of the die with a 3, 6 total sides on a die, so you have 1/6 chance, or 2 of the dice have a 3 on it, or there are 2 3s on 2 dice, and there are 6 total sides of a pair of dice, so that's 2/12. And again, that can be broken back down into 1/6. Again, the steps are you count the total number of possibilities, not just the ones you want, but the total amount that's possible if you were to just close your eyes and select something at random. And that's going to be on the bottom of the fraction bar. So we're going to put number 1, step number 1, on the bottom of the fraction. And then step number 2 is you count the available number of what you want. So there's 4 kings in a deck, or there's 1 3 on a die, or there are 3 roses in the garden. So you want to do step number 2 and write that on the top of the fraction bar. So step number 2 is going to be on the top of the fraction bar. You draw that fraction, you place number 2 over number 1, and that's your probability of selecting what you want.